In this video, we're going to be looking at solving more difficult trig equations. Each example is going to offer at least one unique algebraic or trigonometric technique. Okay, so as we go through all the examples here, they're each a little bit different than each other. Some ideas will be a bit similar, and then some things will be totally different. In example number 1, what I want you to notice first is that our variable theta is only located once within the whole equation. What that usually means is that we can use direct solving to isolate that variable. We just little by little remove everything that is attached to it. Get rid of the 2, the 1, the sign, get rid of that squared, and then eventually we'll have our answer for theta. All right, so thinking that way, we're going to remove everything that's attached to theta. We're actually going to start with the weakest operations, which would be the subtraction that we have here. So first step, what we can do is add the 1 to the other side. Okay, so if you add the 1 to this side, you're going to get 1. Okay, I'm going to go ahead and not write that one because I think we can tackle 2 steps at once here. The second step, after that has been moved over and we got a 1 on the right, we can divide by the 2. So we'll divide the 1 by 2 and we get 1/2. All right, so that will get us to this point. We have sine squared theta is equal to 1/2. We had to add the 1 over and then divide by the 2. All right, next, we need to get rid of the squared because that is technically outside of the sine function. It's outside of that part. So we're going to square root. That would give us the sine of theta is equal to the square root of 1/2. But notice I have a little space here because we need to be conscious that when we take a square root, you can either be getting a positive or negative value from there. That's going to make things interesting here because it's going to split our problem into 2 different directions. One of them is that the sine of theta can be equal to the square root of 1/2. The other is that the sine of theta can be equal to the negative square root of 1/2. We have 2 different options that we can follow here, and both of these are going to work. They're both going to work. What we're going to do next is go ahead and take an arc sine of each of those numbers. All right, so I'm going to use a calculator to do that. This question is set for degrees. Okay, we're going to be taking any answers that are within 1 period in terms of degrees. All right, so I am set to degrees. The arc sine of the square root, I'll type it in as 0.5, is going to give us 45 degrees. Gives us exactly 45 degrees. All right, so we get that. So theta is equal to 45 degrees. However, we have to remember we've got reference angles, right? We got reference angles, and we could actually have multiple answers to go with that one. All right, so the calculator is giving us back 45 degrees, which is over here. And that was when we took the arc sine of a positive square root 1/2. All right, so the other quadrant that we're also positive in for sine is going to be located over here. The other angle that would have a reference angle of 45 degrees would be 135 degrees. So we get that as an answer. Okay, and those are 2. We're going to get 2 more answers looking at this part over here. All right, so I'm going to go to the calculator. It's pretty much the same thing, except we need to insert a negative. All right, and you're going to notice that we get negative 45. All right, so what does that mean? The answer that we get back, so the calculator gives us negative 45. That means that we're rotating down. We're going to rotate down 45 degrees, which is going to put us at 315 degrees. So we got that. And remember, this is because we had a negative square root 1/2. Gives us an answer in quadrant 4. The other quadrant that will be negative is down here in quadrant 3. So we're literally getting answers in all 4 of the quadrants, and they're all going to be using a reference angle of 45 degrees. Okay, so 180 plus 45. Well, first we got 315. All right, 180 plus 45 is going to give us 225. So all of these should work as answers. All right, let's go ahead and check these answers and see if they all work. We're going to type in 2 sine, and then in parentheses, 45 degrees is our first answer, and then we'll square that and subtract 1 and see if we get 0. We do. All right, so let's check our next one. 135. Whoops, got too much there. All right, 135 also gives us 0. All right, and then we had 315 gives us 0. And last, we've got 225, which also gives us 0, and that will be all 4 of the answers that we get within that one period. All right, number 2, we got a bit of a long one here. All right, the equation says sine squared x minus sine x is equal to cosine squared x. We got a lot of x's in here. You got an x here, here, and here. And those x's are all in different things. You got it inside of sine squared, you've got it inside of sine, you've also got it into cosine squared x. Okay, so we can't quite do direct solving right now. That's out of the question because we got too many x's in different places. So the way that we're going to deal with this is to at least make sure that we don't have multiple trig functions. That would be in there. So I'm going to keep everything in terms of sine. Okay, so I'm going to keep this side just as it is. But that cosine squared x, I'm going to use my Pythagorean identity to change that into terms of sine. Okay, I can rewrite that as 1 minus sine squared x. We've used that one a few times before. Okay, but it comes from the Pythagorean identity and just moving around the sine squared x. It would be equivalent to cosine squared x. All right, so everything is in terms of sine now. Next, what I'm going to do is move all of this over to that side. Okay, so that minus sine squared x is going to get added on here, which will give me 2 sine squared x. We also have our minus sine x. That 1 is going to be a minus 1, and everything is equal to 0. All right, now why did I do that? If you take a close look at this, you're going to notice that it sort of fits the idea of a quadratic equation, right? Your sine squared x and your sine x might as well be an x squared and a x, just a regular x. So I'm going to temporarily do that. I'm going to rewrite it this way because you might recognize it as the quadratic better. Okay, now so the sign is important. We haven't lost that. But just temporarily here, what I'm going to do is just treat it as an x. Let sine x be just x because it's less to look at. Okay, and now we have a quadratic. And we might be able to solve that quadratic by doing some factoring. Okay, let's factor by parts here. Let's factor by parts. 2 times negative 1 is negative 2. All right, think of 2 things that multiply to give you negative 2 and add to give you negative 1. That would be negative 2 and a positive 1. So I'm going to call that negative 2x and positive x. All right, negative 2 and 1 multiply to give you negative 2. They also group together to give you negative 1. All right, everything else I'm going to drop down around it. Then factor by parts. Look at what each of these pairs have in common. The first pair, you can divide out a 2 and an x. You can take out a 2x. That leaves you with x minus 1. All right, and then the other one, we need to make sure that matches, so x minus 1. To get that, we're going to divide out a positive 1. We're going to do that. So this will factor. This will factor into 2x plus 1. That's 2x plus 1 and x minus 1. And of course, all this was set equal to 0. Kind of drop that out, but it's there. All right. And then you can set each of these equal to 0 and figure out what would work, right? The answer to this one would be that x is equal to negative 1/2. The answer here would be x is equal to 1. All right, but remember, x is not x. X is actually the sine of x. All right, so the sine of x can equal negative 1/2, or the sine of x can equal 1. All right, so these are the 2 equations that we really need to solve now to get the answers to the original one. And to do that, we're going to be taking some arc sines. All right, remember that the sine of 30 degrees gives you 1/2. Now, this is a negative 1/2, but we'll be able to deal with that by thinking of reference angles. Okay, for sine, we're positive in the top, negative in the bottom. All right, so the sine of 30 gives you 1/2, which means that if you measure 30 degrees into these 2 quadrants, that would give you the negative 1/2. Of course, we're going to be answering everything in radians, though, okay? In radians. So 30 degrees in radians is going to be 30 degrees is equal to pi over 6 radians. All right, so the answers that we'll get for this will be down pi over 6 and down pi over 6 here. That means that our answers are going to be 7 pi over 6, that would be the third quadrant answer. This would be 11 pi over 6. That would be 11 pi over 6 in that spot there. All right, and then for the other one, what angle measurement in sine gives us exactly 1? That would be 90 degrees located right here. Okay, so you only get one answer that actually goes along with this one, which would be at 90 degrees. And in radians, that would be pi over 2. All right, and then all of these you can type into the original equation and see that they do in fact work. Example 3, we've got sine x times tangent x is equal to 3 sine x. Okay, now one of the most important things that you learn from this problem is what to not do. Yes, you do have a sine x on the left and you have it on the right. You cannot divide those out. It is very important that you know that you should not ever divide an x out of a problem, because when you do that, you actually lose an answer. Okay, so what we're gonna do in this one, we're gonna move that over to this side. And some of these techniques that you see here, you don't really know why we're doing them, but once you see enough examples, I was gonna move that over. Once you see enough examples of these, you start to figure out why we do it, and you'll be able to recognize them in the future. Okay, so we're gonna subtract the 3 sine x and set that equal to 0. Now, we've got two terms here. We got that product and we've got this part, which both had the sine x in it that I acknowledged earlier. What we're gonna do is factor that out. We're gonna factor out the sine x, factor that out of the rest, and that'll leave you with a tangent x minus 3, all set equal to 0. And once you see it here, you'll be able to realize that, oh, if this is equal to 0, then the whole thing is 0, or if this is equal to 0, the whole thing is 0. It's sort of like our quadratic problem, but without actually having quadratics involved here. Okay, so we get two equations. We get the sine of x can be equal to 0. We also get that the tangent x minus 3 can equal 0. In other words, the tangent of x equal to 3. Okay, if I set that equal to 0, I could just move the minus 3 over and get this. It saves us a little bit of trouble. We'll then take the arc sine and the arc tangent of these respective numbers, and those will give us our answers. Okay, we'll be doing this in radians. We're going to be doing it in radians, and we're also going to be rounding to the nearest hundredth. So these might not give us those special numbers that we have. All right, so for what values is the sine of x equal to 0? For what angle values do we take the sine and we get 0? Let's take a look at that picture that I always draw. Positive top, negative on the bottom. The places that you'll get 0 are right between the positive and the negative. So at 0 degrees and at 180 degrees. In terms of radians, that would be 0 and also pi. Okay, so the answers that we get from here are going to be at 0 radians and pi radians, which if we needed to round it to the nearest hundredth, we could call it 3.14, but that answer that we know, that answer that we have is exact, so I'll leave it there. All right, for the other one, for that, we're gonna be stuck with decimals here. We'll definitely be stuck with decimals. All right, I am set for radians. I'm gonna take the arc tangent of 3. All right, so it's gonna give me that answer, which I will round to the nearest hundredth, so that'll be 1.25. All right, so you get 1.25 radians. All right, thinking of the picture though for tangent. We haven't had to draw this one very often. All right, tangent is gonna be positive in the first quadrant and also positive in the third quadrant. It will be negative in these two quadrants. All right, so that was a 3, right? That was a 3, and we got back an answer of 1.25. We got an answer 1.25. All right, remember that this is going to be 0, and that is going to be pi in terms of radians, so 3.14. If I take, I'm just trying to size things up here. If I take 3.14 and divide that by 2, I get 1.57. So this is approximately 1.57 up here. Our answer, 1.25, sounds pretty good. It's over here somewhere in that quadrant, closer to the top, so 1.25. That means that our other answer needs to be in a positive quadrant with a reference angle of that. That is gonna put us all the way down here. It's gonna put us down here. You actually get a straight line through there. So we're going to take pi and just add onto it this value. Okay, so I'll just recall that answer. Plus pi, we get 4.39. All right, and that would be all four solutions how we get for this equation. Example 4, we've got 2 sine theta is equal to cosine theta. All right, what I'm actually going to start with in this problem is almost what I said you can't do in example 3 where you're dividing by your variable. But it's a little bit different here. What I'm going to do is divide both sides by the cosine of theta. Divide both sides by the cosine of theta. What I'm not doing here is dividing by something that I plan to cancel out, which is what would have happened in example 3. Okay, when I divide this over, I don't eliminate the cosine theta from the problem, it's still in there. Okay, what I'm really gonna end up doing is attaching it to that sine theta and changing it into a tangent theta. I'm gonna use an identity to change that up. All right, now on the other side, when I divide by cosine theta, when I divide that out, it leaves me with 1. I get left with a 1. All right, so cleaning this up, I got 2 tangent theta, right? Sine over cosine is tangent, is equal to 1. All right, and then what I'm going to do is divide both sides by 2 so that the tangent of theta is equal to 1/2. All right, from here, I can go ahead and take the arc tangent. All right, and let me go ahead and draw that circle again. All right, the tangent circle is going to be positive in quadrants 1 and 3. It will be negative in 2 and 4. All right, so let's switch over to degrees. That, and then take the arc tangent of 0.5. That gives us 26.56 degrees. We'll go ahead and do 2 decimals. Actually, they're going to be 26.57. All right, so we get 26.57 degrees. That would be one answer. Now, this was a positive 1/2. That means that we got an answer over here. It was measuring up 26.57 degrees that way. You can go ahead and extend that line straight out and add that measurement onto 180 degrees. Okay, so 180 plus that last answer is going to give us 206.57 degrees. So those would be the 2 answers that you get here. All right, and last, example number 5. It looks a lot like example 4, except that there is a +1 right there. We have a +1, and unfortunately that changes things significantly. You cannot actually divide by the cosine theta and change it into tangent. This is going to end up being about 10 times as long just because of that +1. Okay, so the way that I'm going to start this is by squaring both sides. Okay, so I'm going to square this side, which is going to give me 4 sine squared theta. Okay, I'm going to square that side. And now over here, when we square this, you need to think about this being a binomial multiplied by itself, and it will give you cosine squared theta plus 2 cosine theta plus 1. I'll let you do that on your own, but this raised to the second power is going to give you that right there. Now, why would I choose to do that? Because sine squared theta, I can relate to our Pythagorean identity. I can substitute in for that 1 minus cosine squared theta. I can do that. And if I do, I've at least accomplished one good thing here, which is making sure that I don't have 2 different types of trig functions. Everything's in terms of cosine now. Okay, so let's distribute that in. We'll get 4 minus 4 cosine squared theta is equal to cosine squared theta plus 2 cosine theta plus 1. And look at this. We've got cosine to a second power, and we've also got regular cosine. That means we can start to treat this as a quadratic. Let's go ahead and move everything over. We'll make this side 0. All right, that negative 4 cosine squared theta can get added onto that. We get 5 cosine squared theta plus 2 cosine theta, and then that 4 will subtract, which is going to give us a negative 3. All right, and now what do we got to do? We got to factor by parts. We got to factor by parts here. Okay, so let's see. Think of 2 things that multiply to give you negative 15. 2 things that multiply to give you negative 15. Multiply to give you negative 15. they also have to add to give you a positive 2. All right, so that would be a positive 5 and a negative 3. So the same numbers that we actually have there. So that might make things work a little bit easier in a moment. All right, so the middle term, I'm going to split that into positive 5 cosine theta and a negative 2 cosine theta. I'll be able to split it that way. Oh, sorry. That would be a negative 3. All right, they need to multiply to give me negative 15 and add to give me 2. So that'd be negative 3. All right, go ahead and drop down the negative 3 here. 5 cosine squared theta will go there. Factoring by parts, we can divide out a 5 and a cosine theta. That was a theta. 5 cosine theta, leaving behind a cosine theta plus 1. All right, and then on the other end, we need to get cosine theta plus 1 if this is going to work. And you can do that by dividing out a negative 3. All right, so that will leave us with 2 equations. So all this is set equal to 0, remember, from there. So we've got 5 cosine theta minus 3 is equal to 0. And we've also got cosine theta plus 1 can be equal to 0. Okay, so here, that changes into cosine theta is equal to 3/5. This cosine theta is equal to negative 1. All right. Don't got much space left. Let's see what we can do. Both of these involve cosine, so positive right, negative left. Let's take care of this one because that's the easier one. All right, where is cosine theta? For what theta is cosine theta equal to negative 1? That would be right here, directly between the two negatives, which would be at 180 degrees. So that would be one answer that we get, and you only get one for this. All right, over here, I'm going to have to do an arc cosine. All right, set for degrees, second cosine, 3/5 is going to give me 53.13. All right, so that angle is about here, 53.13, so that'll be an answer. All right, and then the other quadrant that is positive for cosine is down here, so we need to subtract that from 360. We get 306.87. And those will be the solutions to this equation. Here's the part that you might not like. Sometimes when you're solving problems, you can actually create extra answers that are not really correct. We call them extraneous solutions. And we did that in this problem. One of these answers is actually extraneous. And it happened because at the very beginning of the problem, going from here to there, I decided to square. And when I did that, it brought in an extra answer. The extra answer that we end up with is the 306.87. All right, now the only way that we're really gonna know that that's extraneous though is to check our answers. All right, so I'm gonna at least type in that one. These actually do work out though. All right, so for the one that doesn't work, I'm gonna type in 2, then the sign of 306.87. Evaluate that, and there's your answer. Next, I'm gonna type in the cosine of 306.87 and add on 1. Okay, and at a quick glance, they do look pretty darn close to each other, right? Because that 5,999 basically becomes a 6. But the difference is that that is negative and that this is positive. So the right and left sides of the equation don't actually give us the same value. They give us opposites, which will make that an extraneous solution, and we eliminate it.
Later, blah.